Hello, in this self-help video I'm going to give you some basics for completing the radioactive dating game activity, which is this attached to your weekly work. Let's go over the goals real quick. Identify isotopes that are commonly used to determine how old matter might be. Explain how radiometric dating works and why different elements can be used for dating different objects. And use percent of an isotope measured in an object to estimate its age. So, with further ado, let's go ahead and open up our game, and you'll see how these goals are easily met by playing this game. Here's your Canvas page, and what you'll do is you'll click on this link here, and it'll take a few seconds for the link to open up because it's bringing up on a browser page, so you do not have to download anything. And here we are. So what I recommend is that you have your student response document open already, and as we move through this video, you stop, you play with the game, you answer things in your student response document, and you go back and forth between those three. So when you get to the game, it's going to look like this. And what you're going to do is you're going to have 4 tabs. And the first instruction on your worksheet is to explore the radioactive dating game, try all the tabs, figure out why there is more than one element used to estimate how old things are, what element isotopes are used to estimate how old something is, and why do scientists use more than one type. Be specific. It is not just to get repeated results. Okay, so let's look at our game. We can answer those real quickly. Okay, so in the first tab, half-life, you have 3 different options here, and you're going to learn that the first option is carbon-14. Carbon-14 decays, as you learned in last lab, to nitrogen-14. You could also do uranium, which will decay to lead. So if you look at carbon-14, all we have to do is add 10, and it gives you how fast it decays. It tells you where its half-life is, which is around 5,700 years. And you can reset and do it again. You can pause it, right? Or you can start it. You can add more, etc. Okay? You can do the same thing, but with uranium. Notice that uranium has a much longer half-life. You can add 10. You can pause it. Okay, you can reset it, etc. Okay? And then you have a custom one. And on the custom one, you can actually slide this, and it'll let you make your custom half-life wherever you want to, all right? And then you can go ahead and add 10, and you can see what half-life means, all right? Changing from one thing to the other. It also gives you this wonderful little pie chart up here so you can see how long it takes to completely decay, all right, which is going to be needed for later. Alright, let's move on to our next tab. In our next tab, it just shows you the decay rate. So you can actually, this when you get it, it'll probably be on 0. You slide this and add, and then you just push, and it'll give you the decay rate. So it starts off with uranium, and it changes to lead. As it changes, lead increases, and uranium decreases. Right? So in radioactive dating, all they're doing is comparing how much carbon-14 or uranium is in the environment or in that sample to how much lead is there, and you can get an idea of how old something is by looking at the ratio comparison of those two. How much percent is left will give you an age. Right? So then in the next thing what you're doing is you're actually going to do that for a tree. So we're going to reset, and you can either plant a tree or you can edge a rock. So you plant a tree, and you can see the carbon-14 stays the same because it's in taking, it never goes down. But once the tree dies, the carbon-14 starts to decay, and you can get a percentage of how much is still there and how much is decayed. You can do the same thing for uranium. You have to measure a rock and a tree. And finally, we get to our game. Okay, so in our worksheet, so let me go down to this part of your activity, and here I'm going to want you to find the age of some items right? And so you go back to your game, and you can put your monitor on an item. And I already did this one, and we're going to do it for carbon-14. Instead, I'll say 98.2%, right? And what you would do is you can move this to 98.2, and that means that 98.2% of it is still left, and it'll say, okay, well, that's 147 years, and you would type that into your estimate. So let me show you that with, so estimate the bone, so 83.9, so you'd move this to 83.9. You get as close as you can. Okay, and it tells you how many years, 1,461, so you would type that in there, 1,461, and you can check, oop, we got that one right. All right, so you're going to do that for the items I wanted you to do, which is the tree, the goblet, the dino, the skull, so that you can answer the questions. Now, in some of the cases, you might have to change your scale because it won't work on one. You have to do uranium, or you might even have to do custom. And in the custom, you have to pick the time scale you want. Do you want it to be thousands of years, millions of years, 10 million years, 100 million years, and you would just click whichever one, and that will give you your key. So play with that. I don't want to give you too many hints on that. And then you should be able to finish up the questions here. And the final question, I think, is, if you're a forensic scientist and found a dead buried body, could you use one of the isotopes in the simulation to figure out how old the person died? And then you can explain. If you have further questions, please see your science teacher. I hope this helped. Good luck.